In just 48 hours, an extraordinary event that NASA has been quietly preparing for is about to happen. An object from another star system flying at 37,000 miles per hour will pass within 29 million kilometers of Mars. But there's something they haven't told you. Harvard's Avi Loeb has just given this object a 6 out of 10 on his scale for assessing potential alien technology. This means there's a 60% confidence that it is not a natural creation. And when you see the photos that amateur astronomers have just captured, you'll understand why the scientific community is in a state of absolute chaos. Because it's behaving unlike any comet we've ever seen. It's releasing pure nickel with no iron. This is impossible in nature. It's a situation that only occurs in industrial manufacturing. Its chemical composition is 16 times more extreme than any known comet. Its color changed overnight from red to green. And the probability of its orbital trajectory being random is only 1 in 500. But then, things start to get terrifying. In late September, 3I Atlas will disappear behind the sun for 2 whole months. We won't be able to see it on October 30th when it's closest to us. Loeb suggests this might be intentional, designed to evade our observation when it's at its brightest or when something else happens. Some scientists believe it may have already deployed stealthy Pioneer probes that are undetectable by Earth's telescopes. These probes are small enough to reach Mars while we are all staring at the main object. Over 227 observatories worldwide have been tracking this thing. They have collected over 4,000 observations, and every single data point makes it seem even stranger. It weighs 33 billion tons, which by itself shouldn't exist. The mathematical models simply don't add up. We should have found 100,000 smaller objects before discovering one this massive. So what in the world is this 3AA Tellus? Over the next hour, I'm going to show you every anomaly, every leaked observation, and every theory that scientists are unwilling to discuss publicly. Because after October 3rd, when those Mars probes turn their cameras toward this thing, we might finally get an answer, or we might get something far more disturbing. If you're as fascinated by this as I am, please like this video and subscribe to the channel. And let me know in the comments where you're from, what time it is there, and what's the strangest thing you've ever experienced. Chapter 1. Avi Loeb's astonishing 6 out of 10 rating. Avi just did something that sent shockwaves through the astronomy community. The Harvard astrophysicist, who claimed in 2017 that Mama could be alien technology, has now spoken. He's given 3I Atlas a 6 out of 10 on his assessment scale for potential technological origin. That represents a 60% confidence that this thing is not natural. Before you dismiss this, understand what changed his mind. It wasn't a wild guess. It was data from the James Webb Space Telescope, the Very Large Telescope in Chile, and the Hubble Space Telescope. It found that 95% of its gas plume was carbon dioxide, with only 5% water. For a comet at that distance from the Sun, this ratio is 16 times more extreme than any known comet. Then, the Very Large Telescope detected nickel in its gas plume. Strong, clear emission lines. But here's the kicker. There was no iron. None at all. They are forged together in dying stars and ejected together in supernovae. Finding nickel without iron is like finding smoke without fire. It doesn't happen in nature, but it happens all the time in industrial manufacture. High-purity nickel, alloys, aerospace components. You name it. The signature is consistent with a factory, not cosmic debris. And the nickel production is increasing. The closer it gets to the sun, the more metal it vaporizes. Loeb has faced harsh criticism for suggesting an alien tech explanation, but neither of them has explained the nickel without iron, nor the extreme CO2 ratio, nor the 1 in 500 probability orbit. Loeb himself admits his technological hypothesis is largely a thought exercise. He says the most likely outcome is still a natural comet, but most likely is not certain. And by giving it a 6, he's saying there's a 40% chance we have this completely wrong. The Mars flyby on October 3rd will tell us more. If the HiRISE camera shows a nucleus larger than 5 kilometers, as his mass calculations imply, then the natural explanation completely falls apart. Because there isn't enough rocky material in interstellar space to deliver objects this large this often. Chapter 2: The Amateur Photo That Broke the Internet. Something is going viral on social media that professional astronomers don't want to touch. Amateur astrophotographers are sharing images of 3I Atlas that don't look like a comet. Instead of the expected fuzzy, diffuse glow, some photos show structure, geometry, and hard edges that shouldn't be there. Michael Jager and Gerald Rumman, two highly respected amateur astronomers, captured 3I Atlas on September 7th during a total lunar eclipse in Namibia. The images show the object glowing green with a bluish tint, clearly gas-rich and visible in both blue and green filters. But it's the other amateurs, the names that don't make it into press releases, who have captured what are now being called the structured images. It looks less like a diffuse cloud and more like an object with edges. These are all technically valid concerns when you're imaging a fast-moving object thousands of times fainter than naked eye visibility. Smearing and distortion are common problems. The Asteroid Terrestrial Impact Last Alert System ATLAS telescope that discovered 3I Atlas is only 20 inches in diameter. So when someone with comparable equipment captures unusual structure, why is it automatically dismissed without investigation? Some show a classic cometary appearance with a developing coma and faint tail. Others show something that's difficult to explain. A compact core, an irregular shape, and pixel patterns that don't match the standard point spread function of a star or comet. Half the commenters are shouting image processing errors. The other half are demanding that someone with professional equipment repeat the observations to either confirm or deny, but that's not happening. Instead, professional astronomers are jumping into the threads to debunk, without being willing to check for themselves. One image that went viral on X, formerly Twitter, shows a more compact, less diffuse core than what Hubble captured. The amateur claimed it was taken with a 14-inch Schmidt Cassegrain telescope, stacking 50 individual exposures. This is standard practice for deep sky photography. The pros immediately cited atmospheric distortion, tracking drift, chromatic aberration, anything to explain it away, but not one of them suggested pointing a bigger telescope at the same coordinates. No offers to help verify the observation, only to negate it. And this is where it gets weird. The Hubble Space Telescope image from July 21st showed a teardrop-shaped cocoon of dust, with the glow extending in front of the object, toward the sun. This is official NASA data, and it already violates expectation. Tails are supposed to be pushed away by solar wind and radiation pressure, trailing behind. Then, an image from the Gemini South Telescope on August 27th showed the first evidence of a true antisolar tail, trailing behind the object. So something changed between July and August. Either 3I Atlas started behaving more like a conventional comet, or our viewing angle changed enough to reveal what was already there. Most of the amateur photos claiming unusual structure were taken in that July-August window. This was the period when the object was behaving least like a comet. Even the professional observations showed anomalies. And here's another data point that isn't getting enough attention. NASA's Sphere-X mission observed 3I Atlas in early August, and saw it as a point source. No extended coma, no tail, just a dot. Professionals are seeing anomalies they can't fully explain. Amateurs are seeing anomalies that get dismissed as incompetence. And both are imaging the same object during the same weird time window when it wasn't acting like a comet. The European Space Agency's Mars Express and ExoMars Trace Gas Orbiter will image 3I Atlas on October 3rd. They're using cameras designed to image the surface of Mars from just a few hundred kilometers away, and they'll be imaging this object from 30 million kilometers. ESA has already stated they don't expect spectacular images. It will probably be less than a single pixel in their cameras. But what if the amateurs saw something real? What if there is structure beneath the gas? The October observations might not resolve the issue. We might need to get closer with better instruments pointed directly at this thing, free from atmospheric interference. The truth is, we're flying partially blind. Professional telescopes have limited time and specific observing plans. Amateurs have flexibility but less advanced equipment. And somewhere in the gap between the two, something unusual is happening that neither side wants to fully acknowledge. Because if the amateurs are right, if there is structure inconsistent with a natural cometary form, then we're not talking about an imaging error. We're talking about rewriting our understanding of interstellar visitors. Chapter 3: The Mars Encounter, on October 3rd. What they're not telling you. In 2 days, 3I Aeolus will pass 29 million kilometers from Mars. That sounds like a safe distance. But there's something no one is discussing: its minimum orbit intersection distance. The closest point this object comes to Mars's complete solar orbit is just 2. The HRISE camera on the Mars Reconnaissance Orbiter will image 3I Aeolus on October 3rd at a resolution of 30 kilometers per pixel. That's detailed enough to separate the nucleus from the surrounding dust cloud. It's detailed enough to measure the actual surface area reflecting sunlight, and it's detailed enough to confirm if this object is truly 5 kilometers wide, as Loeb's latest mass calculations suggest. If it is that big, the natural comet explanation completely breaks down. Based on the limited inventory of rocky material in interstellar space, we should have detected about 100,000 smaller interstellar objects, the size of Oumuamua, before finding a monster like 3I Aeolus. But we've only ever found 2 previous visitors, and they were both tiny compared to this. But here's where it gets truly unsettling. Loeb has calculated that if 3I Aeolus deployed a Pioneer probe, a small scout craft flying about 30 million kilometers ahead of the main body, that probe could intercept Mars on or within the week before October 3rd. And the terrifying part is, our telescopes on Earth cannot detect an object smaller than about 100 meters at the distance of Mars. That's roughly the size limit of every spacecraft humanity has ever launched. Any Pioneer probe would be completely invisible to us. This idea isn't as crazy as it sounds. If you were designing an interstellar mission to survey a planetary system, you wouldn't send just one massive ship. You'd send a mothership with smaller scout probes, deploying them ahead of time to gather data from individual planets, while the main craft follows a safe trajectory through the system. And the orbit of 3I Aeolus makes this disturbingly plausible. The object's path would only require a velocity change of 10 to 15 kilometers per second during September to reduce its closest approach to Mars to 0. For a technological object, that's a trivial maneuver. A natural comet, it's impossible. NASA's Mars Express and the ExoMars Trace Gas Orbiter will also observe 3I Aeolus on October 3rd with multiple instruments. High-resolution cameras, spectrometers, particle sensors. They were designed to study the Martian surface and atmosphere, but are now being repurposed to study this visitor. These instruments will try to characterize the comet's volatile activity and composition from 30 million kilometers away. But there's a secondary objective that no one is publicly advertising. HRISE won't just be imaging 3I Aeolus itself. It will be scanning the space around it, looking for anything that might be flying ahead of the main body. Looking for Pioneer probes. Loeb spelled it out in his blog post. Use HRISE to search for objects in front of 3I Aeolus, closer to Mars than the main body. If material from 3I Aeolus reaches Mars in October, and it couldn't have gotten there by natural sublimation and ejection, the timing is also suspicious. 3I Aeolus reaches its closest point to Mars just 1 week before it disappears behind the Sun from Earth's perspective. We get one good look at it with our Mars spacecraft, and then the object vanishes into the Sun's glare for 2 months. It won't be observable again until early December. If you wanted to deliver something to Mars without being seen, this would be the perfect window. Deploy your probes during the October 3rd flyby, while Earth's telescopes are watching the main body. Then the mothership hides behind the sun for 8 weeks, while the probes do their work. NASA's Curiosity and Perseverance rovers may also attempt observations from the Martian surface, although the comet will be very faint from a ground-level perspective. The Mars Reconnaissance Orbiter is our best shot at detailed imaging. And then there's the question of what happens if they do find something. If REES captures an image showing multiple objects, or unusual maneuvers, or anything suggesting artificial activity, what's the protocol? Do they announce it immediately? Do they verify with additional observations? Do they classify it? Protocols for detecting extraterrestrial intelligence are focused on radio signals or optical beacons, not physical craft transiting the inner solar system. In 24 hours, we'll know if what those amateur astronomers saw was real. We'll know if the nickel-no-iron signature means what Loeb thinks it means, and all the speculation will collapse in an embarrassing heap. But either way, October 3rd, 2025, could be a day for the history books. The day we either confirmed 3II Tullus is a weird but natural interstellar comet, or the day everything changed. Chapter 4. The Nickel Without Iron Bombshell. A very large telescope in Chile has just detected something that shouldn't exist in nature. Between late July and late August 2025, spectroscopic observations showed neutral nickel atoms streaming away from 3II Tullus, strong emission lines across multiple wavelengths. It's an unambiguous sign that nickel is sublimating off its surface as the object approaches the Sun. But there was no iron, not a trace. Zero emission lines in all the expected wavelengths where iron should be. Let me explain why this is absolutely staggering. Nickel and iron are cosmic twins. They are forged together in the same nuclear reactions inside massive stars. They condense into dust grains together. They get incorporated into asteroids and comets together. In every piece of space rock humanity has ever analyzed, from meteorites that have fallen to Earth to samples returned by missions, nickel and iron appear in predictable ratios. To find one without the other is like finding hydrogen without protons. The VLT team, led by researchers with no connection to Avi Loeb's more controversial claims, published their findings with a cautiously worded conclusion. They proposed the nickel could be coming from nickel carbonyl, a molecule that could theoretically exist in extremely cold interstellar environments. These compounds are unstable and would break down when exposed to UV light, releasing nickel and carbon monoxide. But even the VLT team admits this would be unprecedented. It's never been observed in any solar system comet. It's never been detected in interstellar space. It is purely a theory proposed to explain an observation that has to be explained. The nickel production isn't stable. When 3II Tullus was first observed in July at 385 AU, that rate had increased by a factor of 25 times more nickel was streaming off its surface in just 1 month. The closer this object gets to the Sun, the more violently it sheds metal. And this growth doesn't follow the gentle curve we see in normal cometary outgassing. It's exponential, steep, as if something is being systematically vaporized by increasing heat. Avi pointed out what no one else was willing to say. And on Earth, we routinely separate nickel and iron through industrial processes. High-purity nickel is used in specialty alloys for aerospace applications, electronics, batteries, anywhere specific thermal or electromagnetic properties are required. The signature we're detecting from 3II Tullus matches industrial nickel production, not natural cosmic abundance. The critics immediately seized on this. They said Loeb was cherry-picking data, engaging in motivated reasoning. Jason Wright of Penn State was particularly harsh, calling the comparison to industrial processes misleading and unscientific. But the critics didn't address the problem. If the nickel is coming from natural carbonyl compounds, Where is the iron? Iron also forms similar volatile compounds. If conditions existed to create and preserve nickel carbonyl in interstellar space for billions of years, the same conditions would create iron carbonyl. They should both be there, but only nickel is. The VLT observations also detected a rapid increase in cyanide production. Hydrogen cyanide and related compounds appeared in the gas plume around 3II Tellus, at a rate that rose sharply as the object neared the Sun. Loeb has suggested the color change from red to green, observed by amateurs, could be linked to this cyanide surge. Cyanide itself is not uncommon in comets. It's a common carbon-nitrogen compound found in many icy bodies, but the rate of increase, that steep production curve that mirrors the nickel release, suggests the processes are somehow linked. What's truly interesting is what this tells us about the object's composition. If the bulk of its mass is in the form of carbon dioxide ice, with trace amounts of water, as the Webb telescope found, and if its surface is shedding nickel and cyanide at an increasing rate, then we're looking at a chemical makeup that doesn't match anything formed in our solar system. Their water-to-2 ratio reflects the temperature and composition of the protoplanetary disk they originated from. 3II Tellus has the opposite ratio. It's CO2 dominant with very little water. This suggests it formed in a very different environment, around a very different star, or it suggests it's not natural at all. And there's a third possibility that no one wants to seriously discuss. What if 3II Tellus is natural, an ancient comet from another star system, but it has traveled through interstellar space for so long that its surface chemistry has been altered? Cosmic rays, impacts with interstellar dust grains, chemical reactions in the near absolute zero vacuum. 7 billion years of exposure could do strange things to a surface composition. Perhaps the nickel-no-iron signature is real, but the explanation is somewhere between a natural comet and an artificial craft, something we haven't thought of yet because we've never studied an object this old, from this far away. The October observations will help. When HIES images 3II Tellus from Mars orbit, spectroscopic data from Mars Express, and the ExoMars Trace Gas Orbiter will capture additional emission lines, more data on nickel production, more measurements of cyanide and CO2 outgassing, placing more constraints on what this thing actually is. But based on the data we have right now, 3II Tellus is bleeding industrial-grade nickel into space while showing absolutely no signs of iron. And nobody has a good natural explanation for it. Chapter 5. The Disappearing Act, Hiding Behind the Sun. In late September, 3II Tellus vanished. Not destroyed, not diverted, just hidden. From Earth's perspective, it moved too close to the Sun to be observed. For 2 entire months from late September through November, ground-based telescopes have a complete loss of signal. The object disappeared into the Sun's glare, and here's what makes the timing so suspicious. 3II Tellus will reach perihelion, its closest approach to the Sun, on October 30th, 2025. This is the moment of maximum cometary activity, when the Sun's heat drives the most outgassing, when its behavior reveals the most about its composition and structure. It's the single most important window for observing and understanding what this thing is, and we can't see it. If 3II Tellus wanted to avoid detailed observation from Earth's telescopes during its brightest, most active phase, this is the orbit that would achieve it. NASA and other space agencies are trying to work around this. The Parker Solar Probe, which is currently studying the solar corona in a close solar orbit, might be able to catch a glimpse if the timing works out. The Solar and Heliospheric Observatory SESO, which stares at the Sun continuously to monitor for coronal mass ejections, will have 3II Tellus pass through its field of view. The object will likely be too dim against the overwhelming brightness of the Sun. The Jupiter Icy Moons Explorer JUICE is currently on the far side of the Sun relative to Earth. It is using its high-gain antenna as a sunshield, meaning data transmission is limited. JUICE will attempt to observe 3II Tellus with its cameras and spectrometers in November, but we won't get that data until February 2026, months after the fact. So for the most critical period, we are effectively blind, with everything that happens on October 30th taking place behind the curtain. So what could happen during these 2 months? If 3i Atlas is natural, nothing unexpected, it will heat up, outgas more violently, maybe fragment if thermal stresses crack the nucleus, and then re-emerge in December, slightly smaller, less active, and headed back to interstellar space. But if it's not natural, if there is any technological component, those 2 months are the perfect window for activity we are not meant to see. Course corrections, probe deployments, trajectory adjustments, anything that requires propulsion or maneuvering would be easily spotted by observers on Earth if we could see it. Loeb has calculated that a velocity change of just 10 to 15 kilometers per second during September or October would be enough to significantly alter the orbit of 3i Atlas, enough to deliver a payload to Mars, Venus, or even Earth. For a natural comet, this is impossible. Sublimating ice can produce a push of maybe half a kilometer per second, at most. But for something with an engine, it's trivial. Another possibility is more disturbing. What if the disappearing act is exactly what it sounds like? What if 3i Atlas doesn't re-emerge in December? What if it uses the perihelion pass to decelerate, to enter a long, elliptical orbit around the Sun, and become a permanent resident of the inner solar system? We won't know until it's supposed to re-emerge in December. If it doesn't appear where the calculations predict, if the orbit has changed significantly, that would be a sign of propulsion, of technology, and of intent. There is a precedent for this kind of thinking, although not with an interstellar object. In 1986, the Soviet Vega probes flew by Halley's Comet and detected something unexpected. The nucleus was much darker than expected, reflecting only 4% of the sunlight that hit it. It turned out they are incredibly dark, covered in a crust of organic compounds and dust. The ice is buried beneath a hard, crusty surface layer. That one discovery changed our understanding of what comets look like up close. And it only happened because we sent a spacecraft to look. Remote observations from Earth had given us completely wrong assumptions. With 3i Atlas, we are back to remote observation during a critical period, inferring its behavior from limited data, making assumptions that could be completely wrong, and we won't know the truth until December 3rd, when it emerges from behind the Sun and becomes visible to ground-based telescopes again. Amateur astronomers are already preparing. Telescopes around the world are being scheduled for observations in early December. Everyone wants to be the first to spot it coming back. Everyone wants to see if it looks different, if its activity levels have changed, if its orbit matches the predictions. That's when the mainstream astronomical community will have to take the artificial hypothesis seriously. No longer a fringe theory from a controversial scientist, but a plausible possibility that needs to be investigated. The disappearing act also means we miss potential fragmentation events. Natural comets sometimes break apart near perihelion. Thermal stress cracks the nucleus. We've seen this happen with several comets that have passed too close to the Sun. If 3i Atlas were to fragment, we wouldn't see the process. A debris trail, changes in rotation. A fragmentation would actually support the natural comet hypothesis, unless what we interpret as breaking apart is actually deployment. It's actually deployment. Multiple smaller objects separating from the main body, each heading for a different target in the inner solar system. The scenario sounds like science fiction, but so does nickel without iron. So does a perfect ecliptic alignment. Maybe not everything, but it will be revealing. Until then, we wait in the dark, hoping the object that comes back is the same one that went. Chapter 6. The Impossibly Large Object. 33 billion tons. A newly published paper has astronomers feeling very uneasy. Richard Cloke, Peter Veris, and Avi Loeb analyzed 4,022 observations of 3i Atlas from 27 observatories between May 15th and September 23rd. They tracked the object's position with extreme precision and compared its actual trajectory to what a purely gravitational path would predict. And they found something astonishing. 3 anomalies is showing almost no non-gravitational acceleration, despite the massive amounts of outgassing detected by Webb and other telescopes, despite losing hundreds of kilograms of material every second. The object's orbit is deviating from a purely gravitational path by less than 15 meters per second squared per day. This means it is incredibly massive, far more massive than its brightness would suggest. The math is simple. When a comet outgasses, the expelled material acts like a tiny rocket engine. It pushes the comet slightly off its orbit. How much it deviates depends on how much mass you expel and how big the comet is. A small comet with active outgassing will show significant non-gravitational acceleration. A large comet with the same outgassing will show less. Webb measured 129 kilograms of CO2 per second. 6. The deviation is below the limits of detection, meaning the object must be enormous to resist that rocket effect. The calculated lower limit for its mass is 33 billion tons, or 33 trillion kilograms, with a nucleus diameter of at least 5 kilometers. This makes 3 anomalies 3 to 5 orders of magnitude larger than the 2 previous interstellar objects. One or more was at most a few hundred meters across. Comet Borisov was maybe a kilometer. This thing is 5 times the diameter, meaning over 100 times the volume and mass. And herein lies the problem. Based on what we know about interstellar space, on surveys of how much rocky and icy material exists between the stars, an object this massive should be incredibly rare, so rare that we should have detected about 100,000 smaller interstellar visitors before finding one as large as 3 anomalies. But we've only found only two previous interstellar objects in all of human history. It's like winning the lottery jackpot 3 times in a row. Statistically possible, but so improbable you start to wonder if the game is rigged. Loeb argues this points to a non-random orbit. If 3 anomalies was deliberately sent to the inner solar system, if its path was chosen rather than random, then the statistical problem disappears. We're not randomly sampling the interstellar population. We're being visited by something specific. Critics say this is absurd. They point out that our detection capabilities have improved dramatically in recent years. The ITLS survey that found 3 anomalies has only been fully operational for the last decade. Before that, we simply weren't looking hard enough. Of course, we're finding more interstellar objects now. The Vera C. Rubin Observatory, coming online in 2025, discovered over 2,000 asteroids in its first 10 hours of operation. Perhaps we will find dozens more interstellar visitors in the coming years, and the statistical problem will resolve itself. But that doesn't explain the enormous mass. Even with better detection capabilities, even if we find more interstellar objects, their size distribution should follow predictions. Small asteroids outnumber large ones by millions to 1. That's why ITS breaks the pattern. It's the largest one we've found by far, and we found it before cataloguing the thousands of smaller ones that should be more common. The lack of non-gravitational acceleration also rules out certain explanations. The rocket-like thrust would have overcome the gravitational binding, and the object would have fragmented. But it's not fragmenting. It's holding together despite the massive loss of mass. That requires either a solid, coherent nucleus, or something holding it together more effectively than its own gravity. The Mars observations on October 3rd could resolve this size issue. If HIES can separate the nucleus from its dust cloud and measure how much light is truly reflecting off a solid surface versus being scattered by surrounding particles, we'll get a much better estimate of the true nucleus diameter. If it's larger than 5 kilometers, the natural explanation becomes very difficult to sustain. There is another possibility that hasn't gotten much attention. What if 3 Atlas is surrounded by a large diffuse cloud of very fine dust, and most of the brightness we're seeing is from that dust, not from the nucleus itself? Then the nucleus could be much smaller, and the mass calculation would be wrong. But Webb and Sphere-X observed in the infrared. The infrared light penetrates dust, revealing the solid surface beneath, and Sphere-X saw 3I Atlas as a point source, not an extended cloud. This suggests there is not a huge dust envelope hiding a tiny nucleus. What we're seeing is basically the object itself. So we're back to a nucleus of at least 5 kilometers, with a mass of at least 33 billion tons, showing almost no non-gravitational acceleration despite massive outgassing. An object that statistically shouldn't exist, arriving on an orbit with a 1 in 500 random probability. The data keeps piling up, and with every observation, the natural explanation becomes a little less convincing, not impossible, but increasingly strained, requiring more and more special pleading, more coincidences, and more unprecedented conditions. Chapter 7. The Chemically Impossible Mystery of the 95% CO2. The James Webb Space Telescope used its near-infrared spectrograph to observe 3I Atlas on August 6, 2025. And what it found rewrote our understanding of what an interstellar comet should look like. The gas plume surrounding 3I Atlas is composed of 95% carbon dioxide and only 5% water. For a comet at that solar distance, this ratio is 16 times more extreme than expected. Every comet we've ever studied from our own solar system has been water-rich. They formed in the cold outer regions where water ice was the dominant volatile. Carbon dioxide was present, but in much smaller quantities. This ratio reflects the temperature and chemistry of the protoplanetary disk where they were born. 3I Atlas has the opposite chemistry. It is a dry ice ball with almost no water. This tells us it was formed in a very different place, around a star with a different composition, in a disk with different temperatures and pressures, an environment completely alien to the one that formed our solar system. Martin Cordiner, the principal investigator for the Webb observations, stated, "This is one of the highest CO2 to water ratios ever measured in any comet." Webb also detected significant amounts of carbon monoxide and carbonyl sulfide. This mix of compounds suggests the object formed in an extremely cold environment, possibly even colder than the edges of our own solar system. Some researchers have suggested 3I Atlas may have originated in a molecular cloud region, or was ejected from a planetary system much farther from its star than our Kuiper belt. Then there's the color change, documented by amateur astronomers in July and early August. Observations showed 3I Atlas with a reddish coma. This color typically indicates organic compounds, complex carbon molecules that absorb blue light and reflect red. It's a standard feature for comets, but on September 7th, during the total lunar eclipse, Michael Jaeger and Gerald Rimmon captured it, glowing bright green with a bluish tint. The shift seemed to happen overnight. Green comets are well known. The color comes from diatomic carbon molecules in the coma, absorbing solar UV radiation and re-emitting it as green light. However, astronomers at Kitt Peak Observatory had already analyzed 3I Atlas in August. They found it to be one of the most carbon chain depleted comets ever observed. It had very low concentrations of diatomic carbon, the very molecule that makes comets green. AV Loeb has suggested the color change might be linked to the rapid increase in cyanide production, detected by the VLT. Cyanogen can also produce a green color under certain conditions. The VLT observations showed a sharp spike in hydrogen cyanide emissions as 3I Atlas approached the Sun. The production rate wasn't gradual, as you'd expect from normal cometary outgas. Stephanie Millam from NASA's Goddard Space Flight Center, who worked on the Webb observations, proposed that 3I Atlas might have a baked outer crust. Billions of years traveling through interstellar space, exposed to cosmic rays and stellar radiation, could have chemically altered its surface layer. Carbon dioxide might have been created or enriched through these processes, giving it an unusual surface chemistry. We've never studied an object this old. The nickel-no-iron signature can't be explained by surface processing. Neither can the lack of non-gravitational acceleration, but taken together, they form a pattern that is becoming increasingly difficult to ignore. And there's the HEFA-X observation, which saw 3I Atlas as a point source with no extended emission. An infrared telescope should see through the dust and reveal the thermal emission from warming ice and rock, but it saw a dot, a concentrated point of infrared emission, consistent with a relatively compact solid object. Maybe its surface is highly reflective, bouncing sunlight away before it can absorb the heat. Maybe there's an insulating layer, preventing heat from penetrating. Maybe the nucleus is rotating so fast that heat is distributed before it can cause significant sublimation. Or maybe it's not outgassing in the way we think it is. Maybe what we're interpreting as sublimation is something else entirely. The chemical data also reveals information about where 3I Atlas might have come from. Low metallicity, high hydrogen, and ice content suggest it came from a region of the galaxy where stars formed early. The thick disk of the Milky Way, populated by older stars that are less enriched with heavy elements. Models place its origin somewhere between 7 and 11 billion years ago, making it a relic from a time when our galaxy looked very different. If 3I Atlas is natural, it's a time capsule from the ancient Milky Way, a piece of primordial ice carrying the chemical signatures of a time billions of years before the Earth existed. That alone would make it one of the most scientifically valuable objects we've ever observed. But the chemistry is always just slightly wrong. With the CO2 dominance can be explained. The lack of water can be explained. The cyanide can be explained. The color change can be explained. Each piece of the puzzle has a potential natural solution, one that requires us to stretch our models a bit, but not break them. It's the combination that's so troubling. It's the pattern of all the anomalies appearing in the same object. The statistical improbability of this specific set of features occurring together by chance. November and December will bring more data. When 3I Atlas emerges from behind the Sun, ground-based telescopes will capture new spectra, more emission lines, more chemical signatures, more constraints on its composition, and by comparing the pre- and post-perihelion chemistry, we'll learn if the solar heating has fundamentally changed anything about the object's behavior. Chapter 8. The Anti-Tail That Shouldn't Exist. The Hubble Space Telescope captured the highest resolution image of 3I Atlas on July 21, 2025. And what it showed violated basic cometary physics. The image revealed a teardrop-shaped cocoon of dust, but with the glow extending in front of the object, in the direction of the Sun. There was no significant tail in the anti-solar direction behind it. This is backward. Comet tails are pushed away from the Sun by solar wind and radiation pressure. The tail should always point away from the Sun, creating the classic, swept-back appearance we associate with comets. But 3I Atlas had its bright side facing the Sun, with no obvious tail behind it. Avi Loeb and his colleague Eric Cato published the only paper in the scientific literature attempting to explain this anti-tail. They proposed the forward glow could be dust grains being pushed ahead of the nucleus by some internal process, but even they admitted this was pure speculation. There is no clear mechanism that would create a forward-pointing dust cloud on a natural comet. They claimed the glow wasn't an anti-tail at all, just a smearing effect from Hubble trying to track the fast-moving object. The telescope was following 3I Atlas as it moved through space, which caused background stars to leave streaks in the exposure. Perhaps the forward glow was just a product of that tracking motion. But Hubble's image processing team knows how to deal with tracking effects. The streaks are clearly visible in the image, and the forward glow is not a streak. It's an enhanced region of brightness, with a defined structure. If it were just a hacking artifact, it should look like the stellar trails. It does not. And suddenly, 3I Atlas had a normal tail, a faint, teardrop-shaped tail appearing behind the object in the anti-solar direction, exactly where a tail should be. Either the object started behaving like a normal comet, or our viewing geometry changed enough to reveal something that was already there but obscured by the dust cloud. The Hubble image in July was taken when 3I Atlas was about 4 astronomical units from the Sun. The Gemini image in August was at about 2.6 AU, but that doesn't explain the forward glow. The coma might be brighter on the sunward side where sublimation is most active, but it shouldn't form a directed glow ahead of the object's motion. There was another puzzling detail in the Hubble image. The dust cocoon extended for about 3,000 kilometers around 3I Atlas. LARP calculated that if the nucleus is 10 kilometers in diameter, the density of dust 3,000 kilometers away would be diluted by a factor of 90,000 compared to the density near its surface. That's a huge drop-off for the dust to still be bright enough for Hubble to detect. Either a tremendous amount of dust was being produced, or the dust particles were extremely reflective, or the scattering geometry was unusual. The Gemini images also showed color variation. In ultraviolet light, the object appeared more compact. In red and infrared light, the dust cloud was more extended. This is consistent with normal dust scattering properties, where smaller grains scatter blue light more efficiently, and larger grains scatter red light. But it also means the size distribution of dust grains is not uniform. There's a population of very small grains close to the nucleus, and larger grains farther out. This distribution pattern can tell us something about how the dust is being ejected. Fast-moving small particles, slow-moving large particles. This is classic cometary behavior. However, the rotation period complicates things. Observations show 3I Atlas is rotating once every 16 hours. That's relatively slow for a small object. A 10-kilometer nucleus rotating once every 16 hours would have an equatorial surface velocity of only about 1 meter per second. That's not fast enough to fling dust grains into space through centrifugal force, so the dust must be ejected by gas pressure from sublimation. Carbon dioxide, sublimating from the sun-facing side, would carry dust particles with it. But analysis of the Hubble images suggests the dust particles are moving at about 20 meters per second. That's much faster than the rotation speed, but consistent with gas drag sublimation. Here's where it gets interesting. If dust is being ejected at 20 meters per second by CO2 outgassing, and if the object is losing CO2 at the rate of 129 kilograms per second, as measured by Webb, then the dust production rate should be considerable, possibly several tons, and that much dust should form a very prominent tail, a bright extended tail visible in professional telescope images. But the July Hubble image shows no such tail, only a forward glow and a diffuse coma. One possibility is that the dust grains are so small they are being pushed forward by radiation pressure before they can form a conventional tail. Radiation pressure from sunlight can accelerate tiny dust grains faster than solar gravity. If the dust grains are smaller than about a micron, radiation pressure will dominate, and the particles could be pushed ahead of the nucleus. But that would create a forward-pointing tail, not a forward-pointing glow. Another possibility is that the dust is being charged by solar UV radiation and is interacting with the solar magnetic field. Charged dust behaves differently than neutral dust. It can be focused or dispersed by magnetic fields, creating unusual shapes. The S-Farix observation by NASA adds to the confusion. It saw 3I Atlas as a point source in the infrared, with no extended emission. No coma, no tail, just a dot. But Hubble clearly saw an extended structure. The difference is the wavelength. Hubble observed in visible light, SFARX in infrared. Dust reflects visible light, but it emits thermal infrared radiation depending on its temperature. If the dust around 3I Atlas is very cold, much colder than it should be at that distance from the sun, then it would be faint in the infrared even if it's bright in visible light. This suggests the dust is not being efficiently heated by sunlight. Maybe it's highly reflective, bouncing light away before it can absorb the heat. Maybe it's composed of a material with unusual thermal properties. The tail situation will become clearer in December, when 3I Italus emerges from behind the Sun. New observations from multiple telescopes at multiple wavelength will show if the tail has developed further, if it conforms to a normal cometary tail, or if it continues to show anomalous features that don't fit the model. Chapter 9. The 1 in 500 orbit. Coincidence. 3I Italus is traveling on a retrograde orbit, with an inclination of about 75 degrees to the ecliptic plane. That sounds extreme, but what it really means is this. The object is moving almost exactly in the same plane as the planets, just in the opposite direction. It is traveling along the same flat disk, where Earth, Mars, Venus, and Jupiter orbit, but going against the flow. The probability of this happening by chance is 1 in 500. Most objects entering the solar system from interstellar space should come from random directions. Space is three-dimensional. There is no preferred orientation. If interstellar comets are just debris ejected from other star systems on random orbits, they should arrive from all angles. Some from above the ecliptic, some from below, some from the side, a uniform distribution across the celestial sphere. But 3I Atlas is almost perfectly aligned with the planetary orbits, offset from the ecliptic by only 5 degrees. It's not impossible, but it's highly improbable. And it's not just the inclination. The orbit brings 3I Atlas close to multiple planets. It passed within 30 million kilometers of Mars on October 3rd. It will pass a reasonably close distance to Venus. And in March 2026, it will come within 54 million kilometers of Jupiter. Each individual close approach is not remarkable. Space is big. Many orbits pass near planets without being intentionally targeted. But the combination, the alignment with the ecliptic plus the multiple planetary encounters, lowers the probability significantly. Loebert calculates the combined probability of all these geometric factors occurring by chance is about 1 in 500. Not impossible, but enough to raise an eyebrow and consider non-random explanations. If 3I Italus was deliberately sent to survey the inner solar system, you would want its orbit to pass near the major planets. You would want it to be aligned with the ecliptic, because that's where the interesting stuff happens. All the rocky planets, most of the moons, the asteroid belt, the potential for life. A survey probe would naturally follow this geometry. Critics argue this is selection bias. The only reason we notice 3I Italus is because it came close enough to be detected. There could be hundreds of interstellar objects passing through the outer solar system, on random orbits that we never see because they're too far away and too faint. The ones we can detect are by definition the ones that come close to the Sun and Earth. This makes sense. Our detection capabilities are heavily biased toward objects that transit the inner solar system, where our telescopes are concentrated. We are likely missing the vast majority of interstellar visitors that stay in the outer regions. But that doesn't explain the specific alignment. Even among those objects that come close to the Sun, most would not be aligned with the ecliptic. Most would have high inclinations, plunging through the planetary plane at steep angles. The fact that 3I Atlas is nearly coplanar with the planets is unusual even among the subset we can detect. Another aspect of the orbit is interesting. 3I Atlas is on a hyperbolic trajectory with an eccentricity of about. This means it is moving much faster than escape velocity. It is not gravitationally bound to the Sun. It came from interstellar space, and it will return to interstellar space. By running the orbital mechanics in reverse, astronomers can calculate where 3I Atlas originally came from. The calculations suggest it originated somewhere in the thick disk region of the Milky Way, likely from a star system that was between 7 and 11 billion years old. That is incredibly ancient. Older than our Sun, older than our solar system. If 3I Atlas formed around a star that old, it has likely been traveling through space for billions of years. The exposure to cosmic radiation, the chemical alterations, The sheer age of the object makes it unlike anything we've ever studied. With its current speed, minus the sun's gravitational acceleration, 3I Atlas was traveling through interstellar space at about 58 kilometers per second before it entered our system. This is typical for an object from the thick disk population. What doesn't match is the timing of its arrival. The 3I Atlas entered the inner solar system in mid-2025, just as our detection capabilities reached the point where we could find it. The Vera Cephirix has been launched. All the infrastructure needed to characterize an interstellar visitor is in place. Is that a coincidence? Or is it timing? If an advanced civilization wanted to send a probe to survey our system, they might time its arrival strategically. Wait until the target civilization has developed enough technology to detect and study the probe. Arrive when there are telescopes capable of characterizing its composition and measuring its orbit. It sounds like science fiction, but it's not impossible. Any civilization capable of interstellar travel is likely also capable of observing a target system from a distance. They could watch for technosignatures, radio transmissions, artificial lights, atmospheric pollution, all signs that a civilization has reached a certain developmental threshold. Our technosignature has been visible to outside observers for decades. If 3I Atlas was sent in response to detecting those signals, the timing would make sense. So of course, this requires accepting that interstellar travel is viable, that some civilization figured out how to send objects across light years, that they chose to send one here, and that they disguised it as a comet. That's a lot of assumptions, but the orbit remains a 1 in 500 probability, a perfect alignment with the plane of the planets, close approaches to multiple worlds, arriving just as we developed the ability to properly study it. The encounter with Jupiter in March 2026 will be telling Sherry. If 3I Atlas maintains its predicted orbit, passing Jupiter at the expected distance with no deviation, that supports the natural explanation. But if there is a deviation, if the orbit changes in a way that can't be explained by planetary gravity perturbations, then we have a problem. Then we have to explain what changed its course. And once you rule out gravity and outgassing, you run out of natural explanations very quickly. Chapter 10. What happens next? Judgment Day approaches. The resolution, 30 kilometers per pixel, will be enough to separate the nucleus from its dust cloud, enough to measure the surface area and determine how big this thing really is. We should have found thousands of smaller interstellar objects before detecting one this massive. The natural explanation requires increasingly strained coincidences. The European Space Agency's Mars Express and ExoMars Tracegas Orbiter will be observing simultaneously, with spectrometers and cameras. Multiple instruments, multiple wavelengths, multiple angles. With all these Mars spacecraft, we will get the most detailed picture of an interstellar object ever captured by humanity. We will also be searching for pioneer probes, objects flying ahead of 3I Atlas that could be arriving at Mars while we watch the main body. Here eyes will be scanning the space around it. If anything shows up that shouldn't be there, if there are multiple objects instead of one, the entire conversation changes instantly. And then, the waiting. We lost line of sight. The object reaches perihelion, its closest approach to the Sun, on October 30th, hidden from our telescopes by 50 million kilometers of burning plasma. 2 months of blindness, 2 months where anything could happen, and we can't see it. Course corrections, probe deployments, fragmentation, whatever happens in that window, we won't know until the object re-emerges in December. December 3rd is the date when ground-based telescopes are expected to reacquire 3I Atlas. Professional observatories are scheduling time. Everyone wants to be the first to see it coming back from perihelion, and everyone will be comparing the post-perihelion observations to the data from before. Has the brightness changed? Has the outgassing increased or decreased? And most importantly, is it where the calculations predict it should be? If 3I Atlas emerges on a different orbit, If its trajectory has changed in a way that can't be explained by gravitational interactions with the sun and planets, that is evidence of propulsion. That is evidence of technology. And that is when even the skeptics will have to consider other possibilities. The chemistry will also tell us more. New spectroscopic analysis in December will show if the nickel-no-iron signature persists, if the CO2 dominance continues, and if any new emission lines have appeared that weren't there before perihelion. The heat treatment of the solar passage could change its surface chemistry in detectable ways, if the object fragments that would actually support the natural comet hypothesis. Natural comets sometimes break apart near perihelion from thermal stress. We observed this happen with comet Shoemaker-Levy 9 before it impacted Jupiter. Fragmentation is normal, unless the fragmentation looks controlled, and unless multiple pieces separate cleanly and head for different destinations, then fragmentation becomes deployment. March 2026 brings the Jupiter encounter. NASA's Juno spacecraft, currently in a polar orbit of Jupiter, might be able to observe 3I Itilis as it passes within 54 million kilometers. Juno has cameras, spectrometers, particle detectors, instruments designed to study Jupiter, but capable of characterizing this visitor. There has been talk of maneuvering Juno for a closer look. Using that fuel to chase an interstellar object instead of studying Jupiter would be controversial. But if the October and December observations reveal something truly anomalous, the scientific case for retasking Juno becomes compelling. ESA's JUICE spacecraft will also attempt observations in November, but due to communication delays, we won't get that data until February 2026. JUICE is farther from Earth, on the other side of the Sun, using its antenna as a sun shield. Data transmission is limited until it can reorient. So we have observations being collected over several months from multiple spacecraft at multiple locations in the solar system. By the spring of 2026, we will have the most comprehensive data set ever compiled for an interstellar object. And that data set will either confirm 3I Itilis is a weird but natural comet from another star system, or it will force us to seriously consider that we are being visited. The scientific community is preparing for both possibilities. Privately, astronomers are discussing what the protocol would be if a technosignature were confirmed. Who makes the announcement? How do you verify an extraordinary claim before going public? What are the implications for planetary defense if more objects follow? There is no established procedure, because no one ever seriously expected this scenario. SETI protocols focus on radio signals and intentional beacons, not physical objects disguised as comets. The closest analogy would be the protocol for announcing the discovery of life on Mars or Europa. Careful verification, peer review, multiple independent confirmations before any public statement is made. But those protocols assume months or years of analysis. 3I Itilis is passing through and leaving. Decisions would need to be made quickly if we want to properly study it. Some scientists are advocating for an intercept mission. Launch a small probe to rendezvous with 3I Itilis before it escapes past the orbit of Jupiter. Get high-resolution images, sample the outgassing plume, measure magnetic fields and particle radiation up close. By the time authorization and funding were secured, by the time a probe was built and launched, 3I Itilis would be long gone. Interstellar objects move fast. The window of opportunity is measured in weeks, not years. This is our chance, our only chance, to gather data on the third confirmed interstellar visitor before it disappears back into the void between the stars. Extract every possible piece of information from the observations we manage to collect, and then wait. Wait to see if our analysis can find a natural explanation for all the anomalies. Wait to see if the statistical problem resolves or intensifies, and 40% is not zero. The universe has surprised us before, something natural but so unusual, so unexpected, that it challenges our models and forces us to expand our understanding of what's possible. The first confirmed contact with technology from beyond Earth, proof that we are not alone, that other civilizations exist, and that some of them have achieved interstellar capability. We will know soon enough. 3 dates that could change everything.